Hi and Assalamualaikum. Today my groupmates and I will present about high performance liquid chromatography or HPLC. My name is Kairin Arina Huri binti Roslal. Meanwhile, my group member are Nur Arina binti Rustam, Nur Rashida binti Muhammad Razali, Nik Asyah Nabila binti Ismat Husaini, and Nurin Atika binti Amir Shahid. My part is going to present about introduction and conclusion. Introduction. The function HPLC is utilize a liquid mobile phase to separate the components of a mixture. Analytes are first dissolved in the solvent and then forced through the column under high pressure. The HPLC is very versatile because of its ability to easily separate a wide variety of chemical mixture which include non-volatile and thermally unstable compounds. For example, organic, inorganic, biological samples, synthetic or natural polymers, and thermal labile compound. For the applications, any compound with solubility in liquid that can be used as a mobile phase, analytical or preparative. It is highly purified compound in small or large quantities. The applications include analysis of sugars, peptides, residues, organic acids, lipids, amino acids, toxin, and vitamin. The objective of this experiment is to observe the orientation time for each sample. The analyte of this experiment is glucose, and the sample are molasses, goji berry, sad honey, and royal jelly.
Hi and Assalamualaikum, I'm Nurin Atika and now I will be moving on to the methodology of the analysis of glucose using high performance liquid chromatography HPLC analysis in various samples. So in this experiment, we are using 4 samples which is molasses, goji berry, sad honey and royal jelly. So for the first sample is molasses. So molasses is a thick syrup that came from a sugar cane. So for the preparation, 50 grams of molasses is weighed and poured into a 250 ml aluminium glass top flask before being diluted with 150 grams of water. Then 1 milliliter of the liquid poured into the volumetric flask of 10 ml and diluted with water on the scale mark using as the working molasses solution. The flow rate was held at 1 milliliter per minute after the column was stabilized with a mobile phase, and 10 microliter of standard solution was injected into the chromatographic column. And lastly, triplicates of each sample solutions were repeated. The column was washed for more than 30 minutes with the mobile phase at the end of each experiment. Next is goji berry. Goji berry is a tiny red fruit packed with antioxidant. So for the preparation, for 2 minutes, 5 grams of goji berry tissue was homogenized in a blender using 5 ml of distilled water. An equivalent volume of 50 ml of HPLC was added and the mixture obtained was vortexed for 5 minutes and then incubated by magnetic stirring at 50 degrees Celsius for 30 minutes. The supernatant was isolated and transferred to a 250 ml flask when subjected to 5 minutes of Rotterdam paper and 10 minutes of successive nitrogen flow to eliminate the trace of HPLC. And lastly, 20 microliter sample solution was directly injected into a column of platinum amino. The column then was with the water after each of the experiment. The third sample is sad honey. Sad honey is a crystallized or honey that has been set over time. So for the preparation, the honey collection was gathered and placed in a 25 ml of glass container. Then they were measured and dissolved in water to achieve a solution of 20 mg per ml. And lastly, 20 microliter of the sample was injected to an Agilent high-plex calcium column in duplicate. And our last sample, which is royal jelly, is a honeybee secretion that used in the nutrition of larvae and the bee queen. So for the preparation, in a 10 ml of volumetric flask, 2 grams of crude royal jelly was added and a water and methanol solution with the ratio of 3/1 was included to create a final volume in the flask of no more than 9 ml. The flask contents are mixed together and the sample was refrigerated and used for HPLC injection within 3 days. In the HPLC analysis, the injection volume of the sample was 5 microliter. This is the analysis summary of the 4 samples of the HPLC analysis. So, in this HPLC analysis using molasses, goji berry, set honey, and royal jelly, the mobile phase illusion is the isocratic mode. Isocratic mode is a separation that employs solvent or mobile phase of a constant composition. Next, the type of the analysis column are carbohydrate column for molasses, platinum amino column for goji berry, Magellan column for set honey, and amino column for royal jelly. And the temperature of the analysis is 30 and 35 degrees Celsius for molasses, 60 degrees Celsius for goji berry, 85 degrees and 30 degrees Celsius for set honey and royal jelly. The mobile phase for 3 samples, which is molasses, goji berry, and royal jelly, are the same, while the other one is set honey, which is using pure water. Molasses is using the ratio of 75/25% volume over volume, acetonitrile over water, 80/20 for goji berry, and 85/15 for royal jelly. And the flow rate for molasses is 10 ml per minute, 1.2 ml per minute for goji berry, 0.6 ml per minute for set honey, and lastly 1.4 ml per minute for royal jelly. And lastly, this is the graph result of the HPLC analysis on each of the sample. So for the first one is molasses with the retention time of the glucose, which is 9.76 minutes. And for the second graph, it is the goji berry with the retention time of the glucose for 8.37 minutes, and set honey for 12.5 minutes, and lastly royal jelly with the glucose retention time of 4 minutes.
For the result part, we have observed the retention time in minute and the average recovery for the glucose in 4 different types of the sample, which is honey, goji berry, molasses, and the royal jelly. For the honey, the retention time for it is 12.5 minutes and the average recovery was 33.90%. For the second sample, which is the goji berry, the retention time for it was 8.57 minutes with the 98.14% for the average recovery. The third sample is the molasses with 9.76 retention time and 100.30% recovery. For the last sample is the royal jelly with the 4 minutes and 97.2% of the average recovery. For the discussion part, we have the 4 different types of the sample, which are honey, goji berry, royal jelly, and molasses. To analyze the glucose by using the high performance liquid chromatography, which is HPLC. The analysis of glucose in the sample 1 is the honey. The column that used in this experiment was Aglan high plus Ca. Then the Aglan refractive index, which is the Ri, has been used for the detector. The mobile phase that used was the pure water, and the flow rate was 0.6 ml per minute. Lastly, the injection volume was 20 microliter, which is the normal size for the sampling. The second sample was the goji berry. The sample was directly injected on the platinum amino column. The detector has been used was the evaporative light scattering detector, which is ELSD. ELSD presents the numerous advantages compared to the Ri detector, such as the sensitivity, the stability, and the compatibility with the Guardian emission. After that, the HPLC analysis will carry out the isocratic illusion by using the acetonitrate and water with the ratio 80 and 20. The acetonitrate has been chosen because it was the strong polarity at the flow rate of 1.2 ml per minute. The mobile phase was digested by the ultrasonic valve. The third sample was the royal jelly. In this experiment, the column that has been used refined to amino. The detector that used was the variant Ri4 refractive index detector, which is RID. The pump that used was the variant model 230. The illusion was performed using the acetonitrate and water with the ratio 85 and 50 as the mobile phase. Acetonitrate has been chosen because it has the strong polarity at the flow rate 1.4 ml per minute. The injection volume was 5 microliter, which is the normal sample size of the sampling. The first sample was the molasses. It used the avenzobar carbohydrate column, which has protector with the guard column. After that, the detector was used is in the experiment was the refractive index detector, which is RID. The mobile phase was composed of acetonitrile and water with a ratio 75 and 25. Acetonitrile has been chosen because the solvent has the strong polarity and the flow rate was 1.0 ml per minute. Lastly, the injection volume was 10 microliter, which is the normal sample size for.
For conclusion part, the advantage of HPLC is greater sensitivity, which means that there are many various detectors that used. Second is reusable column, which is many analyzers can be tested. Lastly is ideal for ionic species and large molecules. Other than that is sensitivity and resolution. The disadvantages of HPLC is coagulation. It is because of the speed of HPLC and depend on different polarities of compounds. Two compounds with similar structure and polarities can exit the chromatography apparatus at the same time or nearly. Next is cost. Although HPLC can often simplify and speed up the process, the cost of developing an HPLC apparatus, although much more efficient, and contribute to more costly.
For the reference part, we have read 4 different articles about the analysis of high performance liquid chromatography, which is HPLC. Reference 1 refers to the honey, reference 2 based on the goji berry, and the third reference was for the orange jelly, and the lastly for the molasses. These all from the